All right, should we get started? Welcome to this session about the state of PowerShell desired state configuration. My name is Egil Ring. I work as a lead architect on the infrastructure team at Crayon here in Norway. I work mainly with Microsoft infrastructure, but with a focus on automation. So I work with products like SMA and also started working a lot with DSC since it was released. So, the agenda for this session. Last year I did an introduction session to desired state configuration, and then it was relatively new. It was released as part of Windows 8.1 and 2012 R2, and it was released just a few months ago when I did my last talk 12-13 months ago. So today we're going to look at what have happened since then, and we're also going to look at some improvements that have come to our recent update. Also, we're going to look at what's coming in the next version in Windows Management Framework 5, which is essentially PowerShell 5. But before we go into that, I want to do a quick recap from the session last year, just to give everyone an understanding about the architecture of DSC and what it is, in case you haven't seen it before. So, what is it all about? The main goal of desired state configuration is, as its name indicates, it's consistency. So we basically want to avoid having unique servers, or snowflake servers, as we may call them. So we want to keep servers at a predefined desired state. And PowerShell desired state configuration, it's not PowerShell itself. It's a standard-based technology underneath, but PowerShell can be leveraged to write the configuration documents, so we don't have to write those manually. And it also opens up for some cross-platform integrations with Linux and hardware integrations such as network switches, which I'm going to talk more about later on. So I believe most of you already have automation in place for provisioning a new server today. But what happens after the server is installed? Then you probably would have some kind of documentation or a checklist to go through to configure, for instance, a static IP address, configure power plants to high performance if it's a Hyper-V host. Lots of checklists that we do manually. So the goal is to avoid having to do this manually. We define all of these things inside of our DSC configuration. The second part is avoiding what is called configuration drift. So I believe most of you have been troubleshooting some kind of issue. You've been searching for the error on the internet, and you found some registry key that is suggested to change in order to solve the problem. Maybe it solved the problem, maybe it didn't, but anyway, the administrator forgot to reset the registry setting, and it was then a non-standard setting on that server. And maybe that will lead to other problems that is not detected right away. So that is kind of the goal there. If there is a problem, we use a technique that we use commonly on client computers today. If there's a problem, instead of troubleshooting for more like 10 minutes, we just redeploy the client. So that's more of the thought behind DSC as well, that we reinstall the operating system and apply the same configuration. And we're also going to talk about, in the next slide, the declarative syntax, which states what we want to accomplish, so we don't have to script how to do things. We'll look into that. And the third point here is idempotence. DSC have kind of an agent which lives in WMI, which checks at regular intervals that the configuration is valid, so that for instance, a service that has been stopped, if it says in the configuration that it should be started, it will start it. But if nothing has changed, nothing will be performed. So that's the concept of idempotence. So it basically enables you to ensure that you have the correct configuration. You can do continuous deployment, and you avoid what's called configuration drift. So let's look more into the declarative syntax. The best way to describe it is to look at both the old way and the new way, which is kind of imperative, which is what we used to when we do traditional scripting, that we, for instance, check if a Windows feature or a server role is installed. If it's not installed, we will install it. So if you have not seen it before, here is the syntax for a desired state configuration. So you can see that we have the configuration keyword at the top left. We give the configuration a name. Node, we state what server or managed node we want to apply the configuration to. And then we define how we want it to look like. We don't say anything about how to perform it. If you look at the imperative example on the left, we see that there we actually are going ahead and running add Windows feature to install it. But in the declarative syntax, we're only stating how it should look like. So under the hood, there are something called DSC Resources, which we will talk more about, which actually implements the logic of installing it. Then we're going to talk about the different configuration phases. There are 3 of them. So if we start with the authoring phase, where you actually create your configuration, because that is something that must be created somehow. So it may be in, for example, the PowerShell ISE on an administrator's workstation, or it might be an automated process, such as a runbook in SMA, which is dynamically generating a configuration based on a template, for instance. So that can be invoked dynamically as part of our deployment process. The DSC configuration can be applied as well. So here is an example of an authored configuration, which looks a little bit like what we saw earlier, where we state, for instance, Windows feature there. That's the DSC resource that will handle Windows features and roles. There we state that we want the web server or the IIS role to be present. We can also set it to absent if we don't want to have it there. So you can basically say in a configuration that you want only the Hyper-V role to be installed, but all other roles should not be installed. So if someone goes ahead and installs the Telnet client, for instance, on a Hyper-V host, it will be removed at the next consistency check. Next is an example of the file resource, where we put some files in the destination path for the website. So this is just a very basic configuration which shows the authoring phase. So this is something you will have to write. Then we have the staging phase, because when you run the configuration that you created initially, you will get a configuration document, a so-called MOF file that I will show you in the demo, that must be staged somewhere. Staging means temporarily saved before it is applied to the target computer. So it may be staged on a local folder on your computer, or basically any folder, a UNC path, or anywhere. So DSC have 2 kinds of modes, if you will. The first one is the push mode, where you're sitting on your computer and you're directly sending a configuration to a computer. If you're doing that, you can just save the configuration document on a local folder and point to that when you're going to apply it to the computer. If you're using pull mode, where you have a pull server, you basically put the configuration document inside of a folder on the pull server. One example path is there, but the path is something you decide when you install the pull server. So then you generate your configuration, but a special thing about using a pull server is that you also must create a checksum, because that is there to verify that the file contains a valid configuration, that someone haven't gone into the document and created an invalid configuration. That is not there for security, but it's there to ensure that the configuration actually is valid, so that an invalid configuration is not applied to a computer. But if you're using push mode, which is the easiest just to get started with testing, you don't need to worry about that. The third phase is the applying phase, where you have authored the document, you have staged it somewhere, and you want to apply it. Then you can use either a commandlet called start DSC configuration if you're using push mode, where you're copying the MOF files over to the pull server if you're using pull mode. So that's the 3 configuration phases. The next thing I want to show you is what the DSC client or the DSC engine does when it gets a document like this. It will basically call 2 functions. The third one is just for getting information about the current state. So it will first run a function called test target resource, which returns either true or false. If it returns true, everything defined in the configuration is fine and nothing will be performed. But if it returns false, the set target resource will be run, and that's the command that will be responsible for implementing what is currently not in the desired states. Get target resource, that will only be called if you're calling, for instance, get DSC configuration to see if the managed resources is in the desired state. So in a nutshell, this is what's needed to build a custom DSC resource. In the box we have like 12 DSC resources. We have file, users, groups, Windows Server roles and features. But that doesn't cover all needs. There are very many DSC resources available in our resource kit, which I will talk more about. But if you want to build your own DSC resource, you basically have to create a PowerShell module with the 3 functions named test, set, and get target resource. Then I want to talk a little bit about the architecture of DSC. Here we're starting with the client side, which is called the local configuration manager. Here I'm just run a command called get DSC local configuration manager to show the settings from a managed node. So here you can see that we have settings such as refresh mode, almost at the bottom, which is currently set to push. But here, if it's here, you can change it to pull if you want to point to a pull server, for example. And here we also have another important setting, which is the configuration mode, which by default it's set to apply and monitor. So then it will apply the configuration, but it won't actually remediate anything that is not in compliance. So if you want that kind of automatic remediation, you would need to change that setting to apply and autocorrect. So the client settings is useful to know that needs to be changed. If you want to point it to a pull server, you need to specify the download manager custom data, the URL to the pull server. Next, we have on the left side an IT pro, which might be you or someone in your department, sitting on his or her computer, writing a DSC configuration document, which is typically stored in a PowerShell PS1 file. When that configuration is generated and run, it will generate a MOF file, which is where the standards-based document lives. If the IT pro decides to use push mode, he will run a command called start DSC configuration to apply the configuration directly to the managed node. Or he can decide to use a pull server, where the client will need to be configured for pull mode. Or we can use automation, so that there is some automated processes in place to generate these MOF files, which might be, for instance, an SMA runbook, as I said earlier, that will dynamically inject our configuration document based on what kind of roles a server have, and so on. And also, you ultimately need some kind of source control on this. So I've inserted a Git repository at the bottom, where you typically store your configurations. Because if something goes wrong, or you lose your configuration, you typically want to be able to revert and go back in time. So source control is essential when you're getting started with this in production. Before I go into the first demo, I want to talk a little bit about what kind of managed nodes we have. You maybe noticed in the configuration document that when we specified the computer name, it said node instead of computer or computer name or something. And that's not a coincidence, because it might be something else than a computer. The managed node might be, for example, a network switch, a storage system such as a traditional SAN, or a Linux OS with the DSC engine. So Microsoft or Dell actually have already switches in the market. The Dell Force 10 switches, 4810 and S55, which already supports DSC, so you can apply a DSC configuration to them in order to manage the switch ports or physical switch. However, for traditional SANs, there are no DSC support yet, but I would expect it to happen eventually. But if you're using a scale-out file server, which is basically a Microsoft file server with typically SAS disks in the backend, you can already manage your storage system using DSC because it's a Windows server. DSC support for Linux is coming. It's currently in a community technology preview, which is not pretty easy to work with, so that will need to mature some, but it is something that will come eventually. So let's go into the first demo. We'll look into the DSC basics. All of my demo files, which I will share, I'll put the URL on Twitter after the presentation. You can just press Ctrl+M to toggle the regions, try to structure them a little bit. And also I put in here in the top a warning on exit, so that if you accidentally run the whole thing, it will... Okay, thank you. Duplicate, of course. Oh, it's better. In the top here, which I said, if you hit Ctrl+M, you can see that I put in some regions. And if you accidentally try to run the whole script, it will just exit, because it's not meant to be run as a whole thing. It's meant to step through each line and hit, for instance, F8 or the run selection button to only run it as a demo, not the whole thing. Sure. Better? As I said in the introduction, DSC is available in PowerShell 4.0 and higher. The system I'm going to run the demonstrations on now is the latest Windows 10 technical preview, which has a preview of the 5.0. But I will also show you some new things in the preview. So there are several ways to find out what version you are running. Then we're going to look into the configuration keyword. I guess if you have worked with PowerShell in the past, you probably used functions where you first have to define it before you can run it. It's the same concept here. You first need to use the configuration keyword, have a space, and define a name for your configuration. And there you go on and specify the computer name, the resources you want to run. For instance, I'm using the service resource here, and I want the spooler to be running. So if I first define this configuration, nothing will be executed, it will only be defined. I can see that I have a command of the configuration type, of the command type configuration. So now it's available to be run. Next we have the DSC Resources. The get DSC resource was in the past very slow. If you have installed some custom resources, it could take up to a minute. Then they fixed it in the first VMF5 previews, but in the latest one, when I have started to implement classes, it's become a little bit slow again. So I expected them to fix it in the future. So here I run get DSC resource, the name of the resource I want to look at, and dash syntax to look at the syntax of the properties I can specify in the configuration. If you look here, how could I know that there was a name and a state property that I could look up using this get DSC resource syntax command. Or if you're using the PowerShell ISE, we also have what is called IntelliSense. So you can basically hit Control plus space here, and you will get the IntelliSense with all of the names. So you can, for instance, specify name and go on to the next line, Control space again, and it will come with the remaining ones. So that's also much easier in the authoring experience. Next, we're going to define and apply a configuration. Here I'm just using the file resource to create a directory in ctemp. So if ctemp doesn't exist, it will be created. The same for the test.txt, where I specify that the contents should be hello NIC. And if the file already exists, I will force it to be overridden. And you might have been wondering, why do you have to specify a name of the resources, for example, temp here? And the reason for that is something called dependencies. So here I want the test.txt file to be dependent on the ctemp folder, because if the ctemp folder doesn't exist, the file can't be created, for instance, dependencies like that. So here I've specified depends on equals, and the name of the file temp directory, which I specified here. So if I specify temp2 here, I need to specify temp2 here as well. So let's go ahead and generate or define this configuration. Now we're going to run it. I have pre-created some variables here for where I want to store them. So I've created a PowerShell drive called nicconf, where I have my demo and script files. So this is where I want to store my configuration files. Then I'm piping it to invoke item just in order to show you how the MOF file looks like. This is typically something you don't want to do. You just run this part. So let's look at how this looks like. So this is the standards-based MOF document, which PowerShell luckily assists us with creating. So this is not something you have to manually write. It's just something you need to know is there and what it's there for. But this is the document that PowerShell DSC is creating for us. So if we look in C, we can see that the temp directory was created a few minutes ago. We first have to apply the configuration using start DSC configuration. Here is specify -wait because we want to wait until the configuration is applied, and then -verbose in order to show some more information about what's going on. So here it states information about, for instance, it couldn't find the file specified. So if we go into here, we can now see that the test.txt file is created with the contents that we specified in the configuration. So now we can run get DSC configuration in order to look at the configuration, or we can use test DSC configuration, which will basically return true or false. Here we can also specify verbose to see some more information about what it's testing against. By default, it will trigger a consistency check every 15 minutes, but if you want to check it more often, you can use start DSC configuration -use existing and optionally -wait. Then it will just trigger a consistency check of the existing configuration. Yeah, we don't have time to go through all of this. We also have the possibility to create our own resources, which I believe David might be talking about in the next session after lunch. So I'm not going to go deeply into DSC resources. And also I have some references here, for instance, what is the default settings for the DSC local configuration manager, how do you find the relevant event logs. The PowerShell team have created a DSC resource to make it easier to work with the DSC Windows event logs. So I'm not going to spend any more time here now because I want to move on and show you the new stuff. Yeah, as I said, DSC Resources, this is also more for reference, where you can go to TechNet to find the documentation about the 12 built-in resources, as well as how you can get started creating your own. We also have the DSC Resource Kit, which now have, I believe it's in wave 9, where we have over 100 resources for working with things like AD, SQL Server, IIS, Hyper-V, and much more. Also, if someone of you have heard about the PowerShell deployment toolkit, which a guy named Rob Willis in Microsoft have created for automating the complete installation of the whole System Center suite with integrations, connectors across the different products and so on. That is also something that is being rebuilt on top of DSC. So there is already a XPDT resource available on TechNet, which you can have a look at, which will install different parts of System Center using DSC. So the main topic of this talk, which is the state of PowerShell desired state configuration itself. As I said, it was first released with PowerShell version 4, which is available down level to Windows 7 and 2008 R2. It was and it's still a set of language extensions to PowerShell in order to create these configuration files. So DSC itself, it's not PowerShell, but it's extensions that makes it possible for us to create these standards-based configuration files. What has not been talked a lot about or anything about by Microsoft yet is actually a major update to DSC, the first version, which was released as part of the 2014 November rollup for Windows 8.1 and 2012 R2. I believe it will be available down level for those of you who are running PowerShell 4.0 on lower OSs as well. But currently it's only available for 8.1 and 2012 R2. It contains a lot of bug fixes. I believe it's more than 100 bug fixes and a lot of improvements that I'm going to show you in the next demo. So that's basically, it's not an official Microsoft term, but that's something I just call it myself at least, the first version of DSC or DSC V1. Then, as part of the next Windows Management Framework, or PowerShell 5.0, we will have the next version of DSC as well, which basically will be DSC V2, which I'm also going to talk about. And as you probably know, Windows 10 will be released sometime later this year, probably sometime after the summer, while Windows Server vNext won't be released until sometime next year. But I expect it, at least personally, that VMF5 will be released with Windows 10, and that there maybe will be some kind of update to it when the server is released. And that will also, I believe it's stated that the VMF5 framework will also be available down level to Windows 7 and 2008 R2. So what we're seeing in the community is that DSC is being adopted. The adoption is increasing pretty rapidly. There are also a lot of third-party integrations on the market. I've just listed a few of them here, but for instance, Chef is one of the larger ones. We are working very actively with Microsoft and in order to integrate with DSC. DSC support for Linux I talked a little bit about. The same goes for network switches. There is also DSC support for managing Microsoft Azure infrastructure as a service, which Alexander will talk more about later today, so I won't spend any time on it here. So the first thing I want to go through is the update to DSC version 1, which came in the November rollup. There was 3 new commandlets and functions, which I'm going to show you in the demo. There was also some updates and improvements to the existing commandlets and functions, for instance, bug fixes or new parameters. So let's remember to change it to duplicate. Then we're going to look a little bit at the local configuration manager, how we can configure it now we just applied the configuration and saw how that worked. But in order to configure the DSC configuration, local configuration manager, we have kind of the old way, which is before version 5 and before the version 1 update that came in November, which was like this. You defined a configuration called LCM settings or whatever you want to name it, specify the name of the computer, specify the local configuration manager resource, and you just specify the properties that you want. For instance, the refresh mode to be pulled, and you point the download manager custom data to a pull server. This was kind of a weird syntax because you had to specify a hash table with some properties which was not very easily discoverable, at least not in the beginning before it was documented. So I'm not going to run this in sake of saving time, but just to show you how it was done. Then we have the new version, which applies to both the November rollup and the next version in PowerShell version 5. Here we have a DSC local configuration manager attribute on the top here, which locks down the whole configuration document to only be valid for specifying LCM meta configuration, which is basically the client configuration. So here I specify that attribute. Then I have this new syntax where I can call settings to configure the pull mode, the configuration ID, and the configuration mode. And here you can see it's a little bit easier to configure a pull server. You can point it to something called configuration repository web for the web pull server and specify the server URL without any weird hash table syntax. And then we generate the configuration MOF file, and we use set DSC local configuration manager to actually apply the configuration. So we're going to do that now. We're going to run this configuration. And we'll look at get DSC local configuration manager. We can see that it changed it to the settings I specified. But here you can see the configuration download managers. It doesn't show the URL. For that, you will need to use select object and expand that property in order to show the details. But at least it's much easier than it was, in my opinion, in the previous one. And here is a complete overview of all of the meta resources that you can configure using the new syntax. Partial configurations, which is a new feature in VMF 5 that I'm going to talk about. Here I'm just basically going to reset it to push mode for my next demo to work. Then I'm going to go a little bit into the next demo, which will show what's new in both the VMF 4 update and the current VMF 5 preview. So here I have three computers we're going to look at. DC01, which is running VMF 4 with the November rollup installed. Link01, which is not having that update installed, so it's basically the first version of VMF 4. And the VMF 5 9926, which is the latest publicly available build of the VMF 5 preview. So here I'm just going to get the PS version table from them. Then I'm going to, so here you can see with what the build version is. Then I'm going to store the available commands in the PS desired state configuration module from each of them. So in the VMF 4 variable, I'm storing it from the Link01. In the VMF 4 update, we're gathering them from the domain controller. And for the last one, we're getting it from the local computer, which have the VMF 5 preview. So basically now we have stored all the commands from the different versions in some variables, so we can do some comparison and see what's new in terms of commandless functions and parameters. So you can see in the VMF 4 update there are a few new things, while in the VMF 5 preview it's even longer. So we're going to look a little bit into the details here. Here I'm basically using a built-in PowerShell commandlet called compare object to see what's different between those two variables. and I'm comparing the name property. So here we can see the three commandlets that I stated in the PowerShell slides, which was new from VMF4 to the VMF4 update. So if we look at the first one of these, we have removed DSC configuration document. The configuration documents, when they are applied to a managed node, they are saved in the Windows directory, C Windows, I believe it's system32 and configuration. There you have a file called current.mof, which is the last configuration applied. You have pending.mof, which is what will be applied on the next consistency check, and you have previous.mof. So we have different kind of mof files there. So this new command is basically there to help you remove these files if something goes wrong, if some kind of corruption or something happens with the mof file, so that you will need to go in and remove it. You can rather use this commandlet or a function instead of going in and deleting files in the Windows directory, which is kind of scary. Also, if a consistency check was running longer than expected, it wasn't very easy to stop it, force it to stop. So that's what this stop DSC configuration commandlet is all about. Update DSC configuration, as its name indicates, it will update the configuration, but I actually misunderstood this myself initially because I thought it would trigger a consistency check, but it will actually trigger a pull request from a pull server. So it will say, hey, go to the pull server, check if something is new, download it, and apply it. So it's not the same as a consistency check. Then we have some new parameters. New DSC checksum, I've gotten a few parameters which is self-describing. But then we have start DSC configuration, which has this -new use existing parameter, which I showed you earlier here, which will basically trigger a consistency check. Earlier you had to trigger a scheduled task called consistency in order to call it manually, but now you can just run start DSC configuration -use existing. And also, as you can see here, the previous problem with -force is now fixed in this build. Then we have some improvements to existing commandlets and functions. Previously there was a bug with the new DSC checksum, so that it didn't work against UNC paths. You would have to first create the mof file locally, generate the checksum there, and copy it to the pull server. But this is now fixed. Same with get DSC resource, as I said. It was very slow. And the get DSC local configuration manager, it shows much more information than it previously did. For instance, LCM state will show you if the DSC client is doing something, if it's busy or if it's idle. So if you look here at the client-side settings in version 4 without the update, we can see that it's not that many. If you look further down and look on the DSC01, which have the November rollup installed, you can see that we have some additional properties such as LCM states, LCM version, makes it easier to check what version it is, LCM compatible versions, and so on. And in the VMF5 preview, we can just run it locally. It's also a few more. For instance, partial configurations, which we will look at shortly. Previously, when you run test DSC configuration, it would only return true or false. And that made it kind of difficult to run it against many computers, remote computers at once, because which computer did that true come from? Which computer did the false come from? It was something that you would have to figure out yourself. But if you look in the VMF5 preview, you can see that it's actually added a property called indesired state. And if you run it against remote computers, the computer name will also, the PS computer name property will be propagated with the computer name. You also have this dash detailed, so you can actually go and see what kind of resources is in the desired state, and which of them is not in the desired state. So that was the differences between the first version of DSC and the November rollup. Now we're going into what's changed between the November rollup, or the VMF4 update, as I'd like to call it, and the VMF5 preview. And you should also know that the VMF5 preview, it's constantly updated, so about every 2 months you can expect to find a new preview online. So this is kind of, it will be outdated in a few months, because there will probably be some changes, but at the time of this talk, this is how it looks like. So here we have the different commandlets and functions. Find DSC resource. I'll go through them individually later down, but you can see it's six new ones. So the first one, get DSC configuration status, which is actually pretty useful, which will show you the status of previous consistency checks. If you just run it without any parameters, you will only see for the last consistency check or action. If you add the -all switch, you will see the whole history from what is available in the event logs, basically. So this has been running for a long time, so it will return much data, so I'm just going to stop it. Then we have another very useful one, which is compare DSC configuration, because this makes it possible to compare a configuration with the actual state of a computer. It's much easier to show you what I mean here. So if you just define a configuration, we state that we want the spooler to be running. I generate a MOF file for that configuration, but here I'm not going to apply the configuration. I'm instead going to run compare DSC configuration, point it to the path where I stored it, and the computer name. Then you can basically see what resources is in the desired state and not in the desired state without applying the configuration. So it's kind of a preview functionality, if you will, which might be very useful and save you some time when you do testing. So here, if I stop the spooler and I run the command again, yeah, this was something that I haven't figured out yet. It's if I run this one again, we'll see that spooler was changed to resources not in desired state. But there is also a new parameter called reference configuration, which I haven't figured out yet. It might be parameters in the preview which actually doesn't do anything yet, but this one I haven't found any information about. Then we have the published DSC configuration, which is also new in version 5, which basically makes it possible to apply or copy a MOF file to a target node without applying it. So it's basically start DSC configuration without the applying phase. So this means that the configuration will be triggered instead of immediately. It will be triggered on the next consistency check, which might be in 15 minutes or whatever you configured it for. So if you run and look at the files in my system32 configuration directory, you can see that pending.mof is from this timestamp. If I run the publish DSC configuration command and we look again, we should see that pending is changed to the current time, which is 11:04. And then I can use start DSC configuration -use existing -wait if I want to trigger it now, but if I don't do anything, it will be applied at the next consistency check. Connect DSC configuration, that is also a new one, which will give some details on completed configuration executions. So here it's also easier to show it instead of trying to explain it. If you just get a random event from the event log, on all the things that the DSC saves to the event log, you will see this job ID at the top of the description if you look in the event viewer or using get win event as I did here. So this is basically a GUID that will be unique for that consistency check or that job which ran. So here we can specify the instance ID, which is basically the job ID, on the connect DSC configuration. So then I will basically connect to that specific DSC job, if you will. So if I execute this now, you will see that I got a job here, and that job will actually represent the consistency check that was run. So if I, for instance, go and gather ID 54, which was the last one, and use receive job, I will actually receive the information, the same information I would have received if I run it interactively with the -verbose switch. So it's kind of a handy way to connect to your past runs, if you will. It might be easier to troubleshoot. Invoke DSC resource method, that's not something I can show you, but it's basically something that makes it easier to improve the interoperability between DSC and tools like Chef and Puppet. Find DSC resource is for searching against the PowerShell gallery, basically. You can also use find module, which is part of the new PowerShell get module to discover and install PowerShell modules, where you can find DSC resources pretty easy. You can, for instance, search for all modules in the gallery. That includes DSC resources. And the PowerShell get is actually a topic of its own, who would deserve its own session, so I'm not going to talk more about that now. So to wrap up what I just showed you, there are also some other enhancements in the update that's not visible the way I showed it to you, but there are some language enhancements, enhancements to the pull mode, enhancements to credential handling, a lot of things that I've just left here for your reference, basically. So a lot of things that is ported to VMF5 preview is also now available in VMF4, because there was a lot of kind of breaking or show-stopping bugs, if you will, which also is now available for V4, which makes sense. What's new in DSC V2? That's basically what I went through in the last demo. This is also more for your reference, but I also want to highlight some things from the release notes. So if you go and download the latest VMF5 preview, which is from November, you can see that they have different, highlighted the DSC scenarios in yellow, but you can see that they have a design status of stable or experimental. So what Microsoft have said that it's actually supported to use this in production, at least the stable ones. And if something is not working or there's a bug or anything, they will fix it and it will be released in the next version of the preview, which might be released during the next 2 months. And I also have described what's enabled by previous versions of the preview. This is also more for your reference. I've picked out a couple of these, which I'm going to go through, which is something called internode dependency and cross-computer synchronization. So the scenario, if you look at the domain controller and the client at the top there, if you deploy, for instance, a new lab environment for yourself, you don't want to deploy the client before the domain controller, because the client can't join the domain before the domain controller is up and running and the domain is available. So basically with this new built-in resources called wait4, we can create dependencies like this. So we can start the configuration on both computers at the same time, but the client will wait until the domain controller has successfully applied its configuration and the domain is up and running before it will try to join the domain. So this will make it much easier to do internal dependencies on cross-computer synchronizations, but This is something that I would like to highlight. Is not end-to-end orchestration. That is something you would like to use a product such as SMA or other orchestration products for, but it will solve many of the more easy challenges with the dependencies cross computers. For more information, you can look at a very good article by Ravikant Jaganti at the PowerShell magazine, which I'll link to at the bottom. The next topic I want to talk about is partial configuration, which is also based on a very good article by Ravi. Partial configurations makes it possible to fragment your configurations into, for instance, a OS configuration, a SQL configuration if it's a database server, and maybe some security guys want to apply some hardening settings. So with the initial release, there was no way we could send partial configurations to a target system. We would need to put everything into the same document. So it's like if you think of group policy, it was like we only have one group policy, so you have to put everything in that. But with partial configurations, you can have several configurations with different people author. So here is an example of how the architecture looked like, where you can set up either one or more PUL servers, and you can delegate permissions to the database administrators, the security guys, and so on, to have access to and update those configurations. So this will be my last demo. It will be the partial configurations and the cross-computer synchronization. So first we need to specify in the First we need to specify in the local configuration manager that we want to use partial configurations. So here we can see that I'm pointing to a PUL server which I configured in my demo environment. And here I define the partial configuration keyword, if you will, and give the configuration a name, which is osconfig, or might be anything that you want to call it. And also a separate one for SQL config. So here you can say where the source for that partial configuration is, and then you point to the PUL server that you specified here. So let's just go ahead and run this to configure the client to use partial configurations. So now we applied those settings to the client. So now it knows that it should look for an OS config and a SQL config. Next I'm going to just simulate some things, because we don't have time here to complete our OS configuration and complete our SQL configuration. So I'm just basically going to use the file resource and create a file called SQLconfig status.txt, which says SQL is installed and configured. And the same for OS, so that you can understand the concept without us having to wait for the installations. So here I'm going to basically define two different configurations, which in theory could be authored by two different groups of people or two different people. One creates the SQL one creates the OS one. Then we need to specify the PUL server config folder. So here you can see that it's currently empty. Then we need to generate the configuration file for the OS, and this is something that will be named, need to be named in a specific way. So it needs to be named the name of the partial configuration, which is osconfig, then a dot, and then the GUID of the client. So this is not something that is fixed for you in the current preview. That's why I went ahead and run rename item and added this prefix to it. I then have to generate the checksum, since this is the PUL server scenario. I run the exact same steps for the SQL config. And then I use the new update DSC configuration commandlet to trigger the client to go out to the PUL server, check for new new configurations, and here we see that it will apply it. So if you go into ctemp, we should see that we have some files here that is created. The last one is cross-computer synchronization, which for some reason did not work on the latest preview, the Windows 10 preview. So I will jump over to the previous one, which was the November preview, to show you this demo. So here I'm basically specifying a config data variable where I specify the names of the nodes and what kind of roles I want them to have. So here I have a web server role, and I have a server with some other role. So I'm just specifying this description of my environment. Then I'm going to show you a demo of the cross-computer synchronization, where I basically run a configuration where this some other role, the server with some other role, is dependent on the one with the web server. So here we specify that it should wait for all the resources in the remote IIS resource. So let's just go ahead and run this. You will need to specify credentials for the lab or the demo scenario. I'm just going to type it interactively. So now we created the configurations, and if you look at it when I apply it, we should see somewhere here that the remote resource was not available. Here it looks like I didn't uninstall IIS on the computer before the demo, but if I'd done that, you would see that one of the messages there would be that the remote IIS is not available, so it would wait and check for in 10 seconds, for example, that if it's available. So this is basically the concept of cross-computer dependencies. Then there are also from the release notes some functionality that is in early stages of development, such as centralized DSC error reporting to get a central view of all the errors for your DSC clients. So this is also more of a reference to let you know it's there. So before wrapping up, I just want to talk a little bit about DSC. Is it the answer to everything? It's basically orchestration and/or configuration management. Although DSC version 2 supports internal dependencies, it does not replace orchestration tools such as PowerShell Workflow, SMA, Azure Automation, and other third-party ones. So it will not be an orchestration tool, even though it supports some basic level of it. A very common question is, will desired state configuration replace group policy? In the long run, maybe many years, it probably will, but it will take some time. And the second follow-up question to that is, what will happen if DSC and group policy is trying to configure the same setting? And then I want to quote a good quote from Jeffrey Snower, which says they will fight like two raccoons in a bag, basically. So if group policy changes it, DSC will change it to the other setting again on the next run, so they will just go back and forth. So it's not a good idea to use both technologies to configure the same setting. So it's all about using the right tools for the right job. As you know, anything that can be scripted in PowerShell can be put into a DSC resource, but it doesn't mean that you should do it all the time. You should always consider, is this the right thing to do? Then we're almost finished. I put in some links and resources. I will tweet this link on Twitter if you follow at Egil Ring on Twitter. And also leave some references to the PowerShell TechNet documentation, PowerShell team, and some others. Also for reference, here are the other PowerShell-related sessions at NIC. There are some more that will come up later today with David O'Brien after lunch, which is also about DSC, and with Alexander later after that one, talking about Microsoft Azure infrastructure as a service, how you can manage that using PowerShell DSC. And I would like to wrap up this session with the same key takeaway picture, if you will, as I did last year, because I think it's still very valid. Take time to think how you do configuration management, because this is very classic that we can see to many customers is in the same situation, that they don't have time to automate because they're too busy. So start evaluating DSC, even though if you don't have any plans to use it right away. I personally have a feeling of DSC like with PowerShell. When PowerShell 1.0 came out, it wasn't adopted very much, but it had to mature and grow, and people had to start get to know it. In version 2, it was adopted even more when we got remoting, and all the basic bug fixes was removed and so on. And then in version 3, in Windows 8 and Server 2012, it just exploded with 2,500 commandlets in the operating system. So that's basically what I expect to happen with DSC as well. It will take some time to get DSC resources to manage all aspects of your environment, basically, but it will happen. So even though you can't use it maybe today, you should start looking at it and start evaluating when you can use it. It's also a point to make that DSC is not a complete product itself. I want to clarify that it's a platform to build upon. So there is no console you can go into to see all your DSC clients. That is something you will have to write on your own in PowerShell. You can use third parties such as Chef or others that integrates with DSC, but today we don't know if Microsoft will come with a management story for DSC, for instance, System Center or something else, but time will show, I guess. The last slide, I have included my contact info. So that was basically it. Thank you for coming.